Hi everybody. So in our 4.3 video, we're going to talk about parallel and perpendicular lines. All right, hopefully those are words you've heard before. So parallel is like train tracks, right? So parallel are two lines that are never going to intersect. So they were kind of running along the same path. All right. And what that means, if you looked at those lines there, you would see that they have the same rise over run. Same rise over run, which means that parallel lines have equal slopes. Right? And so that's a fact about parallel lines that we need to know. Their slopes are equal. Okay. Perpendicular lines, on the other hand, so perpendicular lines, they don't just cross. They cross in a very specific way. They cross in a way that makes a right angle. Okay, so perpendicular lines, you see them all over the place. They're, the way walls meet, the floor tiles, roads intersect at right angles often. So perpendicular lines, when we look at their slopes, the slopes are opposite reciprocals. So we say opposite reciprocal slopes. All right, so the opposite part means positive or negative. So whatever the original slope is, the other slope is opposite. So one positive, one negative. Reciprocal means flip the fraction over. All right, so flip the fraction over. Okay, so on this next slide, we'll do some examples. All right, so here I give you three slopes, and what we want to do is write a slope that's parallel to each of these given slopes. Right, and so from the page before, we know that parallel slopes are equal. So this is actually a really easy set of problems. Okay, so we use a little symbol. So remember, m means slope. So if I want to write a parallel slope, I do m with a little, like, it kind of looks like a tilted 11. That symbol means parallel. So this is the parallel slope. M parallel equals, well, they're the same thing. So the parallel slope for 2/3 is 2/3. Okay, and number 2, the parallel slope, m parallel, equals -6. It's always the same answer. So if I ask for a parallel slope, it's like a freebie. It's just the same number. So m parallel in number 3 is 84. Now when I ask for a perpendicular slope, then you've got to do some work. So you have to do opposite reciprocal. Opposite, those two words you got to get like stuck in your head. Opposite reciprocal. Okay, so the symbol for perpendicular is an upside down T. So if I'm going to write the m perpendicular, it looks like that. M perpendicular, perpendicular slope. So opposite means I look at the sign of the original as positive. So my new one's going to be negative. And then I flip the fraction over. So that's the reciprocal part. So -4/3. So what this means is if I drew a slope, if I drew a line that had a slope of 3/4, and then I drew another line that had a slope of -4/3, they would intersect each other at right angles. Okay, so now let's do the rest of these. For a slope of -2, my perpendicular, m perpendicular, okay, I have to do opposite. Well, this one's negative, so my new one's going to be positive, and I have to reciprocal this. Well, I need a fraction here, so I'm going to make it 2/1, and so when I reciprocal it, it becomes 1/2. So the opposite reciprocal of -2 is +1/2. All right, number 6 here, m perpendicular. This one's negative also, so my answer is going to be positive, and 1/3 becomes 3. So the opposite reciprocal of -1/3 is +3. And then finally, my m perpendicular, the opposite reciprocal of 5 is -1/5. So change the sign, flip it over. Change the sign, flip it over. That's how we get a perpendicular slope. Alright, so for the rest of this video, we're going to do kind of the meat of this section, which is writing equations of parallel and perpendicular lines. Okay, so in number 8, it says write an equation of a line that's parallel to y equals 3x plus 2 that goes through the point -4, 6. So I want to draw a little sketch of at least what this sort of looks like here. All right, so if I have the line y equals 3x plus 2, that would be up 2, and put my y-intercept there. And then my slope is 3, so it's going to go up 3 more over 1. So up 3 over 1 is there, and then that's my line. So now my job is to write the equation of a line that's parallel to that, but that goes through the point negative 4, 6. So to get to the point negative 4, 6, I would go 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So negative 4, 6 is there. So I'm looking for a line that has the same slope, it's parallel, but goes through that point there. So I'm trying to draw the equation, or write the equation of that purple line, right? They're parallel, but they go through different points, right? So one thing that's really important to note is they don't have the same y-intercept, right? The red line, my original, oops, let's draw that in red here. The red line, the original, has a y-intercept of 2. But my purple line, well, the y-intercept, I don't know what it is, but it's going to be way up here. It's not 2. So I can't just write the same equation. So I'm going to write the first thing I need is the slope of my original. So my slope of the red line is m equals 3. Now if I want a parallel slope, I write m parallel equals, well, parallel lines have the same slope. So my m parallel is also 3. Right? And now I have a slope, and I also have a point, negative 4, 6. So my best and easiest equation is point-slope form. So that's y minus y1. So y minus 6, the y-coordinate is 6, equals 3 times x minus x1. X minus negative 4 is plus 4. And there's my equation. So that line is parallel. This equation represents a line parallel to the red one, and that goes through the point negative 4, 6. Okay, now in number 9 here, this is a y-intercept, 0, 8. If we look at that point, that's a y-intercept, which is nice because now I can use slope-intercept form. Write an equation of the line parallel to y equals negative 5x plus 2 that goes through the point 0, 8. Okay, well in this case, my m, my original slope, is negative 5, which means my parallel slope is also negative 5. And in this case, I know that b is 8. My y-intercept is 8. And that's all because this y-coordinate, or x-coordinate, is 0. I know that's a y-intercept. Okay, so now I can write my final equation. Y equals mx plus b. Y equals negative 5x plus 8. Okay. It's important to see the difference. I can't use slope-intercept form in number 8, problem 8, because I didn't have a y-intercept, I just had a point. All right, 2 more quick problems. All right, number 10 and number 11 here are now about writing perpendicular lines. Okay, so the same idea holds true. Okay, in number 10 here, y equals 2/5 x minus 3. I'm trying to write something that's perpendicular to that. So I'm going to have to do a quick sketch. 2/5 x minus 3 would look something like up 2 over 5. It would look like that. So I want to go through the point 5, negative 1, right there. And then it's going to be perpendicular, so it's got to go like that. So I'm looking for, let's draw that in a different color here. I'm going to write the equation of the purple line. Okay, so in order to write an equation, you need a slope and a point. I have the point, I need a slope. So my original slope that I want to be perpendicular to is 2/5. So my perpendicular slope, m perpendicular, is the opposite, negative, reciprocal, 5 over 2. I flip the fraction over. And now I have a slope and I have a point, so I can write the equation y minus negative 1, so y plus 1 equals negative 5/2 x minus 5. Point and slope. We're trying to find slopes so we can write equations. All right, number 11 is probably the hardest type because, again, I'm trying to write perpendicular to this equation here, but that equation is not in slope-intercept form, so I don't know the slope, and I need to know the slope. So I'm going to solve that for y so that I can find the slope. So I subtract 6x from both sides. I get negative 4y equals negative 6x plus 12, and then divide by negative 4 everywhere. And that leads me to the equation y equals, that's going to be positive 3 halves x minus 3. Okay. So, remember, I'm trying to be perpendicular, and that goes through the point 0, 1. So now I know my original slope. My original slope is 3 halves. M equals 3 halves. So I need my m perpendicular. My perpendicular slope, think about it for a second. Answer it yourself. It's opposite, so negative. Reciprocal, 2/3. So the slope and the point for my answer are negative 2/3 and the point 0, 1, which is, woohoo, a y-intercept. So I can write y equals mx plus b. Y equals, use my perpendicular slope, negative 2/3 x, use my y-intercept of 1 plus 1. Okay? All right, that's all. Thanks for watching.